All right, let's do systems with three variables now. Previously, we've learned how to do systems with two variables using elimination and substitution and graphing. Now let's look at three variables. So, a system in three variables, the graph of an equation in three variables all to the first power is a plane. That's actually the solution is a plane. The solution of a system of three equations in three variables can have one solution, infinitely many solutions, or no solution. And solving a system of equations in three variables is similar to solving systems of equations in two variables. And we use the strategies of substitution and elimination. So here we have a picture for those of you who are visually inclined. Yeah, if you're not, if you're like me and this is just intimidating, don't worry about it because we aren't graphing them. But if you're a visual person and you want to know what one solution looks like, it's where three planes intersect. Infinite solutions is where they intersect at a line, and no solutions could be one of these three situations where they don't have a point in common to all three planes. Okay, so the solution is going to be an ordered triple, and it's in three variables. So like an ordered pair we're used to, where it's just x comma y with the parentheses. Now it's x comma y comma z in alphabetical order. So let's do an example. We have a system of equations here with three variables in three equations. And what we're going to do first is use elimination to make a system of two equations in two variables. So you're going to choose pairs of equations and eliminate one of the variables. So one of the equations you're going to use twice. The other ones you're just going to use once. Okay? And because the x coefficient on the first equation is 1, so that x is all by itself, that's a good one to eliminate because we can just multiply to get rid of these two x's. Or you could use y, you could use z. But for our example, we're going to use x. So, to eliminate x using equations 1 and 2, those are the first two equations if you look back in your notes, we're going to multiply each side of the equation of number 1 by what? We want the opposite of 2. The opposite of 2 is negative 2, so we're going to times the entire equation by negative 2, which gives us negative 2x minus 4y minus 2z is negative 20. Then we're going to take the second equation and rewrite it. Now we're going to just do elimination here. So we're going to add the 2, and we see that our x's cancel, and we're left with negative 5y plus z equals negative 25. Now we're going to take that same first equation, because we can reuse one equation, and we'll take the third equation that we haven't used yet, and we still are looking to get rid of the same variable that we got rid of up here. So we got rid of x's here, so we have to get rid of x's here. Whatever variable, it doesn't matter. You just got to make sure that you're getting rid of it in both situations. So again, we have an x and we have a 2x. We want the opposite of 2, so we're going to multiply the whole equation by negative 2. Once again, we get negative 2x minus 4y minus 2z equals negative 20. Then we're going to copy this equation again. 2x minus 3y minus 5z equals 27. Because we're doing elimination, we're just going to add the two together. Once again, our x's drop out, and we're left with negative 7y minus 7z equals 7. So, we need a y and a z in our first equation, and a y and a z in our second equation. Okay? Now, we know how to do this. We have a system of equations with two equations and two variables. let's try to get rid of the z because there's no number in front of the z, that the coefficient is 1. So what do we have to multiply to get the opposite of -7? Oh, we have to multiply by +7. When we do that, we get -35y plus 7z equals -175. Don't be concerned about the big numbers. It's totally okay. Then we rewrite this second equation. Then we add the two together. And now our z's are going to cancel. So we get -42y equals -168. Pull out a calculator, divide both sides by -42, and we get y equals 4. All right, the hard part is done. Now we have to put that 4 into one of our two variable equations. So let's put it in this one, this top one. -5 times 4 plus z equals -25. We multiply it out and then we add the 20 and we get z is -5. There we go. Now we have 2 of the 3 pieces and we go through and now we have 4 for y and -5 for z, and we're putting those in the original equation and we're multiplying and then combining like terms and then subtracting the 3 and we get x equals 7. So now we have all 3. We have our x, our y, and our z, and we have our answer. Remember, the answer is now in ordered triple, so we have 3 and it's in alphabetical order. This is the x, the y, and the z. Okay, so now this one does not seem so straightforward. We don't have any isolated variable. So let's just take the first 2 and solve for a. Now 6 and 9 both go into 18. One of them has to be positive, one of them has to be negative. So let's times the top by 3. 3 times 6 is 18. And the bottom by -2. -2 times 9 is going to give us -18. So we know our a's are going to cancel. And we multiply it out. And then we multiply out the bottom. And we add. And you know already what's going to happen here. Our a's cancel, our b's cancel, our c's cancel. We're left with 0 on the variable side. And positive 12. And does 0 equal 12? No, of course it doesn't. So the equation 0 equals 12 is never true. So there is no solution to this system. Have a great day.